So welcome to another session of General Chemistry 2. For this day, we're going to cover the most essential learning competency 4, which refer to explain the properties of water with its molecular structure and intermolecular forces. So what are the unpacked learning objectives? Number 1, identify the molecular structure of water, immediately followed by number 2, for us to be able to identify the intermolecular forces of water or between molecules of water. And lastly, for number 3, relate the properties of water on its molecular structure and intermolecular forces. So I hope that you still remember our discussion, or you still have the general idea about intermolecular forces. These are referring to the forces between molecules. Alright, let's just have a brief review of the different intermolecular forces that we have covered. So in terms of the strength, these are arranged in terms of the strength of the intermolecular forces. The strongest force is called ion dipole, followed by hydrogen bond, which is a special kind of dipole-dipole forces, or only slightly stronger. Then we have the ion-induced dipole, dipole-induced dipole, and the dispersion forces. So let's now identify the molecular structure of water. First, let me discuss the three models presented here on the upper topmost picture. We have the structural models A, B, C. So the first model is called a ball and stick model, while letter B is called a space filling model, and letter C is called a structural formula based from the chemical formula of water, which is H2O, with partial charges. So let's now go on with predicting the molecular geometry and hybridization of water. So in terms of describing the molecular structure of water, we can number one, use the electron geometry, and number two, use its molecular geometry. But first, we have to understand first the nature of the central atom, which is oxygen. So oxygen belongs to group number 6, meaning if we divide it by 2, we will have 3 electron groups. And this lone oxygen, pairs with 2 hydrogens. That's why the bond form is called a covalent bond. But due to the electron negativity of oxygen, the oxygen concentrates its electrons on its side. That's why it's forming a partial negative side. While the hydrogen, since they are electron deficient, they are forming the partial positive sides. That's why when you count it, the bonding groups, since oxygen forms 2 covalent bonds with hydrogen, we have 2 bonding groups. And for the lone pairs, from the original number of 6 minus 4, we are left with 2 electrons, which is pertaining to the one lone pair of electrons. So 2 and 1. So in terms of electron geometry or the hybridization, it is called trigonal planar for water. While for the molecular geometry, we will count the bonding groups and the lone pair, A pertaining to the central atom, X for the bonding group since it's 2 and 1 lone pair. So the molecular geometry of water is called a bent structure. So, and please take note that on letter C, we can see here that a molecule of water has a partial positive side, and on the hydrogen side, the molecule of water has the other way around. So oxygen has the partial negative side, and hydrogen, on the two hydrogens, we have the partial positive sides. So they form a dipole, much like our Earth, which has the north and south pole. So let's now have the identification of the intermolecular forces present. So let's concentrate on letter C. So it's the structural formula of one molecule of water. So let's imagine that you have another letter C or another water molecule. So without knowing the concept of hydrogen bonds, mostly you will see that from the earlier discussions about water, they are forming from dipoles or they are forming dipoles. So in the general sense, you can classify the intermolecular force as dipole-dipole forces. But in chemistry, since the 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 molecular interaction between two molecules of water are slightly stronger than the normal dipole forces, so they utilize a specific term for it and refer to it as hydrogen bonding. So hydrogen bonding is a special type of dipole which is stronger than the normal dipoles. And of course, it also has dispersion forces because all molecules so that are interacting, they all have dispersion forces, which is the weakest type of intermolecular force. So let's now relate the properties of water on its molecular structure and intermolecular forces. So let's try first to discuss the intermolecular forces. So since water has both the dispersion forces and hydrogen bonding, we can refer to these two as van der Waals force. Since van der Waals forces is a general term which includes dipole-dipole and London forces, or the dispersion forces. So, since water has van der Waals forces, and generally it's a polar molecule, which is a byproduct of it being composed of hydrogen bonds in terms of its interaction with other molecules. Hydrogen bonding causes high surface tension, low vapor pressure, high specific heat capacity, high heat of vaporization, and high boiling point. So that's how we relate the intermolecular forces and molecular structure of water. So both of these two, the molecular structure of water, which is a bent structure in terms of the molecular geometry, and the intermolecular forces, which are called van der Waals forces, brings about the characteristics of water, which are again high surface tension. You can connect it with our all discussion. You may picture ng water on the leaves. Low vapor pressure, high specific heat capacity. So that's why water or the ocean is called a heat sink. That it's absorbing heat from the sun. It also has very high heat of vaporization. So the amount of energy needed to transform a liquid to a vapor to its vapor forms. That's the vaporization energy, and it has a a high boiling point in terms of other liquids. So let's now define the properties of water and somehow give an example for each. So for cohesion, or the attraction between molecules of the same substance or two molecules of water. So an example would be two water molecules on a leaf bump into each other and form one large water molecule. So that's for cohesion. Because water molecules tend to preserve the least amount or the smallest surface area because of its high surface tension. How about adhesion? It's the attraction between molecules of different substances. So water drops stick to the ends of pine needles. So if a water drops on a pine or on any surface which has greater attraction on a water molecule, they tend to stick. So that's the property of adhesion. Let's now go to the property called high heat capacity, or the amount of energy required to increase the temperature of a substance, such as water. So in the early summer, the ocean temperature is much colder than the air temperature. How about high heat of vaporization? The amount of energy required to turn liquid water into a gas. So boiling water releases steam, yung usok. The steam is water that has changed from a liquid to a gas. And water is less dense as a solid. So as water freezes, it becomes less dense. This means that ice can float on liquid water. So a layer of ice covers the surface of a lake in the winter. So in other countries with 4 seasons, they have the so-called winter, wherein most of the lakes in such countries are covered with ice. So ice floats on water, which is a reflection of its property, wherein water is less dense as a solid, or ice is less dense than so water or ice is less dense than liquid water. So it generally floats on water or liquid water. So for your simplified activity for this video, it's activity 5, unique properties of water. The same directions. For number 1, suppose you add another lone pair in the molecular structure of water. What do you call its structure in electron and molecular geometry? And number 2, what is the electron and molecular geometry of the molecule H3O? And lastly, for number 3, what are the implications of the said properties of water to making life possible on Earth? So thank you. That's the end of our session for this day. Please take care and have a good day.